next speaker, Dr. Anil Narayanan ji, is a former scientist at ISRO, the Indian Space Research Organization. He has a PhD degree in aerospace engineering from IIT Madras. Dr. Narayanan has authored many papers and online articles. He has authored 2 books on Indian astronomy, namely History of Indian Astronomy, the Siamese Manuscript, and History of Indian Astronomy, the Tiruvallur Tables. These are available on Amazon. Dr. Narayanan has authored several papers online on Indian astronomy. He is now working as a consultant in Washington, D.C.
So, folks, I knew that this audience was going to be a varied audience. Some of you are probably experts in astronomy. Some of you are in the middle, maybe. Some of you are beginners. So I really scratched my head. Okay, what shall I talk about? So after a lot of thinking, I thought maybe I can talk about something that's of interest to everybody. Okay, so I thought of talking about 2 topics. Okay, wonders of Indian astronomy and mysteries of Indian astronomy. Who doesn't like a mystery, right? Everybody likes mysteries, right? So in Indian astronomy, there are lots of mysteries, and also many wonders, right? Obviously, we don't have a lot of time, so I thought, I'll take one wonder. Okay, this is probably, in my opinion, the greatest wonder, and the sad part is most of you probably have not heard about this at all, right? The pulsating epicycle. Pulsating, okay, this is something. And then on the mystery side, the location of Lanka, right? So I guess all of you are familiar with Lanka, and there is a mystery out there. Okay, what is the location of Lanka? Is it Sri Lanka or is it somewhere else? Okay, so there is a mystery there. And the last topic, will be the Chaldean connection. So I don't know if you know, Chaldea is the ancient name for Iraq, right? And there is a deep connection between India and Iraq. Iraq meaning the Mesopotamian civilization, right? So there is a deep connection there, and there is also mystery there. Okay, so we'll talk about that. Okay. Get a drink of water.
Certain topics. Certain topics.
So briefly about myself before we begin. I'm Anil Narayanan, a former scientist at ISRO. I am not a professional astronomer or a historian, but ancient astronomy is my hobby and passion for the last 2 decades. I've authored several papers and articles, and also I have authored 2 books on astronomy. So before we start, let's to get you warmed up, right? Let's have some astronomy basics, right? So if you imagine that you are an ancient Indian astronomer, okay, or you're just an ancient Indian person. So when you look up at the sky, what do you see? Right? You see a big dome, right? It's like a big dome. Now on that dome are fixed a few things like stars, sun, planet, moon, meteors, and comets, right? Do you know what is the difference between these 2? These are actually 2 categories of objects. Okay, stars is one category, and okay, do you know what is the difference?
Distance.
So the first one, the stars, they are fixed, right? It looks like they don't move, right? So they form patterns, right? And these patterns are fixed forever. Okay, I mean they're not really fixed forever, but they are fixed for a long time, right? So our ancestors of, let's say, 2,000, 3,000, 4,000 years ago, they saw pretty much the same patterns that we see, like Saptarishi or something, right? Pretty much the same patterns, right? And the other category is those other things. So these all, the second category, they have a motion, right? So the first category is fixed, and the second category is movable, right? And it's good that we have a fixed background, right? Against which doesn't. For example, right? If I move like this, right? You can see I'm moving because this thing is fixed. Sorry. Sorry. So So what I mean is the fixed starry background, right? It's actually a good thing, right? Because if there were no stars that are fixed, or they were also moving, like if this is moving and I'm moving, you can't tell if I'm really moving or not, right? So that's the good thing, okay, about the fixed stars. So in summary, the fixed stars, they form a convenient background against which we can measure the motion of the other bodies. Okay. So let's now briefly talk about the sun. So you all see the sun, right? You think you know quite a bit about sun? Okay, we'll see. Okay, we'll test your knowledge. First question: what color is the sun? Yellow.
Depends on the time of the day.
Depends on the time of the day. Okay. So the actual color of the sun is pure white.
Pure white.
That is the actual color of the sun. Okay. So anything else you see is a atmospheric effect.
Yep.
Right. So is there something pure white here? Okay.
That's what.
So that is the true color of the sun. Right. The other. Hold it. So, got it. Okay. Sorry about that. The other thing, you can say, like when you see the full moon, right? It's pure white, correct? Have you ever wondered why it's pure white?
Reflection of sun.
Yes, correct. It is reflecting. So, some people think that moon is white because the moon rocks are white. No. The moon is white because the sun is white. Okay, so that's the big thing. Okay. So let me ask you another question then. Okay. The sun rises in the east, right? Sun rises up in the east, goes up, sets in the west, right? So you would say the motion of the sun is east to west?
Yes.
Right? No objection?
Apparent.
Okay.
Perceived, apparent. Yeah.
Okay, you guys are smart, okay. So what if I tell you that the actual motion of the sun is west to
West
east?
to east, yeah.
Would you be surprised? Okay, we'll see, okay? We'll see. So, the first motion, right? So the sun has two motions, right? And the sun has two motions because the earth has two major motions, right? So if I am the earth, so if I'm the earth, right? The observer is here, right? So if I'm moving this way to the left, to me, all of you are moving this way.
Yep.
Correct? So it's as simple as that, right? So the earth has a rotation, so that causes us to feel that the sky is rotating in the other direction, east to west, right? So the sun, as somebody said, has no motion. Relative to the solar system, the sun is in the middle, it's not moving at all, okay? But the earth has two motions, rotation and revolution, right? So these two motions produce for us a motion for the sun, right? So the first motion, which is east to west, it is actually the entire sky that's moving, right? So during the day, you cannot see any stars, right? Because the sun is so bright. You cannot see anything in the sky, basically. So it appears that the sun is rising, but really, the entire sky is rising, right? So let's say you by some means you can see the stars. Let us say, okay. So what would you see? So this is the first motion of the sun, and the date is December 23rd, 2017, and you are in Mumbai, okay? Can you see this properly?
Yeah.
Okay. So at 8:15 in the morning, you would see this, okay? So what do you see? You see the sun is here, right? And this is a constellation, a Sagittarius. It's December, so sun is in Sagittarius. This is at 8:15, okay? 3 hours later, at 11:15, what do you see? The sun has risen up, right? And so has Sagittarius, right? So relatively, the sun has not moved, right? The entire sky is moving up, right? This you would see if you could see the background during the day. Of course, you won't be able to see that, right? So is this clear? The first motion of the sun is not a motion of the sun at all, right? The sun rising is not a motion of the sun, right? Okay, now let's look at the second motion of the sun. I think this is probably most of you might not be aware of it, okay? So this is the orbit of the Earth around the Sun. So here is the Sun. Here is the Sun. And this is the orbit of the Earth. Okay? And this is the background stars. Right? You see those signs of the zodiac, right? So let's take the case where the Earth is at A. Right? If the Earth is at A, you would see the Sun in Aries. Right? Okay. Now, after 6 months, the Earth comes here and point B. Now the Sun is in Cancer. Do you see? Okay. So, what happens is that this is an actual motion of the Sun. Right? You really see the Sun dropping back every day. Okay. So let's take again that example from Mumbai. So it's August 2017, and the Sun is in Cancer. Okay. So where will it be in next month? September 2nd. Where is the Sun going to be? Any guesses? See, it's fallen back, right? Now it's in Leo. After 1 month, right? So what happens is that the sky rises every day, but each day the Sun falls back a little bit. Okay, every day 1 degree. Okay, so then after 30 days it has fallen back. It has gone into the next zodiac sign. Okay, so now you talk about your sun sign, right? Your sun sign. Now you know what that means, right? It means where your Sun was at the time you were born, right? Okay, so is this clear? So this is an actual motion of the Sun, right? And this is what astronomers from ancient times were more interested in, because they didn't know it's the Earth moving, right? They thought it's the actual the Sun is moving. Okay. All right. So I hope that is clear. Okay. Okay. So here is the same picture. But now, I have caught it, when it is just moving into Leo from Cancer, right? You know that it falls back every day a little bit, right? So let us say it is now on the border of 2 signs, okay? The Sun is now equally in 2 signs. So this is called Samakranti. Sama means equal, Kranti means, measure, okay? So the Sun is, at this point, is equally in 2 signs, right? And this is when the Indian new month starts, right? Okay. So you have heard of Sankranti, right? So really, if you look at this, you should have 12 Sankrantis every year. So what is that one in January? Makara Sankranti. So you know what that means, right? It means the Sun is entering into Makara goes, right? And that is special, okay? That's why. But really, you have 12 Sankrantis every year, right? Okay, moving on. As the Sun, right? The orbit of the Earth around the Sun is an ellipse, right? So it looks something like this, right? So this is the Earth, and the Sun. This is the orbit of the Sun, okay? So you can see, right, at some point the Sun is close to the Earth, and at other point it's far away from the Earth. Okay? So here's a question for you. You may be surprised again. Where is, so at this point the Sun is closest to the Earth, right? Is it summer there or winter? Summer? That is January 4. Middle of winter. Is that a surprise? Okay. So summer and winter is not caused by the Sun coming closer or further, okay? Summer and winter is caused by something else, right? But it is a surprise, right? Most people who hear this, they get really surprised. What? The Sun is closest to the Earth on January 4th, and it is farthest away on July 4th, okay? So that is the hottest month in the northern hemisphere, right? Yeah, so the Sun is pretty surprising. Okay, so going back to this one, right? The other thing, that not only is the Sun at different distances, it also varies in speed, right? So when the sun is closer to the earth, it is moving very fast, right? And as it moves away, it becomes slower and slower. So the slowest point is here on July 4th, and the fastest is at January 4th. Okay. So remember we said that this thing is divided into 12 signs of zodiac, right? Okay. So what that means is that the sun covers 1 month at different times, right? So if it is going slow, to cover that one sign of zodiac 30 degrees, it will take longer, right? Because it is going slowly, right? And on the other side, it will be faster. Do you see? Right? So the sun travels unevenly, right? So it will cover that 1 month, it covers one zodiac sign at different speeds of the day, okay? So this is really interesting because if you see the next slide, so if you take Western months, right? So starting from April, right? April has 30 days, March has 31 days. So is there any logic behind this? Do you know? I mean, who said April should have 30 days?
Rome, Gregorian calendar,
Somebody did it, right? Somebody in Europe, Julius Caesar, somebody, okay? So this is pretty much arbitrary, okay? Now you have seen the Indian time, right? So the next slide might be a surprise for you. So these are the Indian months. Do you see how beautifully it varies? Right? So interestingly, the longest month is in July. Remember, it's the slowest, right? So the longest month, and the longest month is interesting. It's called Jyeshta, which means elder brother. I don't know. Is there a connection? Why they named it like that? Or anyway, it could be a coincidence. Okay. So isn't that interesting, right? The Indian months have a logic and a reason. Western months arbitrary. I mean, if you made April 31 or March, 30, it doesn't make any difference. But Indian months, the length of the months is deeply connected to the sun. Okay. Now, there's another thing perhaps you're not aware of. So, time in the Indian system is based purely on the sun. And the last thing is probably maybe another surprise for you. If you know the time, the Indian time, you also know exactly the position of the sun. Right? So this is, they do in astrology muhurta and all, right? This is the basis of that, okay? The time tells you exactly the position of the sun up to the minute. Right? Okay. All right, folks. So that was the fun and games. We just getting you warmed up. So now let's go on to the main topic, which is wonders of Indian astronomy, right? Which is the pulsating Indian epicycle. So this is a technique in Indian astronomy to find the position of planets, of the sun or the moon. Okay. Now the moon and the planets is quite complex. So it's highly technical. I'm not going to talk about that. We'll talk about the sun. The sun is the simplest epicycle. Okay, so we'll just talk about that. Okay, the pulsating epicycle of the sun. So as we just saw, this is the orbit of the sun around the Earth. Okay, so the sun is closest to the Earth at the perigee P, and farthest at the apogee A. Okay, and the second point is the sun moves fastest at P and slowest at A. Okay. Now imagine you're an ancient Indian astronomer, right? Put yourself in his shoes. Okay. So he has done all the observation. He's got the data, and he plots it like this. And he said, hey, "What's going on? Why would God make something like this?" Right? I don't know if you know Einstein, when he was told about quantum theory, that it uses probability. So you know what he said? He said, "I don't believe it. God won't play dice." Okay. So even, right? God doesn't play dice, right? Okay. So even these, these geniuses, right? They also have this feeling that when they are researching into something fundamental, it must be elegant, it must be beautiful because it is a work of God. Okay. Now you are the ancient Indian astronomer. You see this. It doesn't look elegant. What is this? See, the Earth is off center, and then sometimes it's faster, sometimes it's slower. It doesn't look elegant, right? Why would God make a figure like this, right? So he's probably thinking, okay, that if I was God, I would make something like this, right? Earth at the center and the sun going at uniform speed, right? So this is called uniform circular motion. Okay? So he's thinking, okay, I wish it was, it should have been like this. Why is it like that? A circle would have been so elegant. Okay, so he scratched his head, walked up and down, trying to figure out, why didn't God make it like this? Okay. Then after a long time, he got the answer. A circle on a circle. I'll explain it. Okay. So that is the epicycle. Okay. So how does it look? It looks something like this. Okay. So the Earth is in the center, and there is a nice circle around it. So this circle, this main circle, that's called the deferent circle. And what is going on the deferent is not the planet, but another circle, right? And the planet moves on that second circle, right? So this is uniform circular motion. This is uniform circular motion. Okay. Okay, now I would like to show you a demo of this thing, okay? Okay, so this is just a small program, I built to show you. So this is the Earth, this is the deferent, this is the epicycle, this is the planet. The red is a planet, okay? So let's see what happens, okay? So the epicycle is going to go counterclockwise, and the planet is going to go clockwise on the circle, okay? So let's see what kind of orbit we get. See, it's coming closer, okay? And now it's going further, right? Nice. Okay, so let's do one thing. There is a trace function. I'm going to put the trace on. Hold on, let me just finish it. Okay, so there is a trace function here. So as the planet moves, it'll leave a trail, okay? So we can see the orbit. Okay, let's stop it. So you see the orbit, right? So using two uniform circular motions, the Indian astronomer produced an orbit that very closely resembles actuality. Right? So, okay. Right. So this is, a very simple case of the epicycle. Okay. So this is just a very simple case of the epicycle. Okay. So the epicycle is really powerful, right? And this is just one epicycle. If you put two epicycles, you can, 3, 4, 5, 6. You can produce almost any curve. You can make an orbit that traces this disk. Okay. It is so powerful. Okay. So just to show you, I'll do one other case. Okay. So what we'll do, we will increase the speed of the epicycle, okay? I'll double the speed of the epicycle. Okay, and put the trace.
previous thing. We're confused. Earth goes around the sun.
That's how it appears.
That's how it appears. Yes, yes. Remember, the ancient astronomer, he didn't know the Earth was moving. For him, the sun is moving. Okay. All right, folks. So this is the second case. So I've doubled the speed of the planet on the epicycle. Okay, let's see what kind of orbit we get. Okay, what is this? Ellipse?
Simple ellipse.
Simple ellipse. Simple ellipse.
Like an ellipse. Yeah.
Ellipse. Okay. All right. What else? One more. Last one. Okay. Let me do minus 30. Minus 30. Trace. Sorry. Thank you. You guys know this is better than me. I'm not sure what this is. Oh, this is a cardioid. Cardioid, very good. Looks like a heart, right? Cardioid. Okay. So, okay. All right, folks. I think you have got it right. Okay. So this is just one epicycle, okay, and you can get a variety of orbits, right? So this is the ingenuity of the Indian astronomer, right? Using the epicycle, right? Okay, let's go back to our presentation.
Sir, is it a part of Surya Siddhanta? What is reference?
Yes, it is. It is.
In this one, both matched exact circle times. So the other planets' motion is not taken into account.
I'm not sure.
So one complete circle matches with the other one because planet is staying exact same.
Right. No, wait. It is not an exact match.
Okay.
It's not, I'll tell you, okay? So, so moving on. Okay, so, I just made various combinations, okay? So these are the orbits that you get, right? So the first one is just a simple circle, right? So that is, the orbit is still a circle, it is offset, okay? Second one, ellipse, cardioid, and then nephroid, three-point star. And look at the last one, a straight line. You can even get a straight line, okay? So this you will get, if you make the epicycle as big as the deferent, and these are the parameters, okay? So bottom line, it's a very, very versatile tool, right? The epicycle. Okay. So here is something. If you go to YouTube, right? So somebody has made a system with 100 epicycles, 100 epicycles, okay? And using that, he has traced out a orbit that's an elephant, right? And there is one other guy who has done something else. I'll wait for you to tell me what it is. It is. It's out there. So
Somebody has a lot of time on this.
somebody's exactly. But these are students of mathematics. Okay, so this is what they do for a living, right? But still, it takes a lot of time for 100 epicycles. Make it okay. So, but I guess you're all convinced, right? The power of the epicycle. Okay, so we have one other problem, right? So remember our orbit, right? It is basically just a shifted circle for latitude, right? So we measure the latitude from the equator up and down, right? What about the longitude? So we have something called the prime meridian, right? So our current prime meridian, it goes through Greenwich in England, right? So all countries have, said that, okay, we will agree that this is the prime meridian, okay? So we measure the longitude east or west based on this.
I didn't agree.
Okay, so the question is, where was the Indian prime meridian? And the answer is, it passes through Lanka. Right? So that is one thing. And the other thing is, Greenwich is here, right? In Lanka's case, Lanka is on the equator. So it passes through Lanka and Lanka is on the equator. Okay. So this is the verse, okay, which says that. So it says that the prime meridian, it passes through Rohitaka, which is Rohtak in Haryana, and Avanti. Avanti is the ancient name for Ujjain. Okay, so the Indian prime meridian passes through Rohtak and through Ujjain. Okay, so it looks something like that. Okay, so this is the Indian prime meridian, right? So let's zoom in. This is it, right? So there's Rohtak, there is Ujjain. Looks like Lanka should be somewhere here, equator. Do you see anything there?
Pangaea.
What's going on?
Pangaea.
Okay, before that, let me tell you one interesting fact. This distance is exactly 500 miles, 100 yojanas. Let's see. Okay. So is this cool? This is really cool, right? Okay. So the distance from the tip of India to the equator matches exactly what Ramayana said about okay. Okay. So you don't see anything here, right? How about we zoom in?
Mauritius, Malay.
Hey, something is there. What is this? No. This is a separate country.
Madagascar, Malay. Mauritius, Indonesia.
Maldives. I think he's been there. Your book is there. Okay. So this is a separate country by itself. It's the Maldives, and it comes from Maladweep. Maladweep is a chain of islands, right? And this is Lakshadweep. Okay, and this belongs to India, but this is a separate country of its own. Okay, so can this be Lanka? I mean, the Ramayana says that Lanka is a big island.
That's all Akhand Bharat. Part of Akhand Bharat.
Lanka. So, guys, so there's supposed to be a big island there, right?
What about
This
sea
island.
level?
What do you think happened to the island?
Submerged.
Submerged? Why?
Sea.
Ocean rose? Okay, so when would there have been an island? When the ocean was down?
Yep.
Ice age? When was the last ice age?
10,000.
10,000 BC? Okay, interesting, right? So the Ramayana could be 10,000 years old?
Right.
I'm not saying anything. Okay. Alright, so this is Maldives, there is Lakshadweep. Okay, and just in case you're interested, so you know about the continental shift and all, right? Okay. So there are these plates, right? When the plates they collide, either it goes up as a ridge or one goes the other. Okay, so at that point there is this thing called the Chagos-Lakadiv Ridge. Okay, so so like those are the high points and low points. Okay. Okay, never mind. Okay, so summary. Lanka holds a preeminent place in Indian culture, mystery, and astronomy. Right? Neither the Ramayana nor ancient Islam agrees with Sri Lanka. Okay, I think you got it. Let's move on. Okay, the next and last mystery. I'll take another 5 minutes. The Chaldean connection. Okay. So as I mentioned, right, the Chaldea is ancient Iraq, right? And India and Chaldea have an ancient connection. So let's get some background on it, okay? So have you heard of the word fertile crescent? Right, so the Middle East, is a pretty much dry area, right? So it's like, desert and semi-desert. In the middle of that, there is a region that is very fertile, right? So here, for example, this is the the low reaches of the Nile River, right? So this is where the Nile slows down and it starts dumping all the good silt and all that, right? Very fertile. And here is the Israel, the Jordan River, and then on this side are these two huge rivers, okay? The Tigris and the Euphrates, right? Okay, so this is the Fertile Crescent, right? So this is Mesopotamia, right? This is the land between the two rivers. it's called Al Jazeera. So now you know where that name comes from, right? But Al Jazeera is owned by Qatar, right? Qatar is this small pimple here, right? What has this got to do with that? I couldn't figure out. Okay. So anyway, they've called their network as Al Jazeera. So now you know what that means, right? Al Jazeera. There's a land between the two rivers. Okay. So let's focus in on here. So those are the two rivers. It's flowing. It starts from Turkey, Syria, Euphrates. Okay. So as you can see, right, this is a very fertile area, right? Now, as I mentioned, right, when the rivers reach the sea, they slow down, right? They slow down, and many thousands of years ago, this whole area at the bottom, right, the southern part was a marsh. Okay, nobody can live there, right? So around 4000 BC, this river had a shift. Okay, so earlier it was like this. Okay, then it shifted up, and then more area became available for cultivation, right? And some group of migrants moved into that area. So these are called the Sumerians, right? So 4000 BC, some people from somewhere moved into this area, and they're called the Sumerians, right? So, yep. Okay, so let's move on. So many people speculate, okay, where are the Sumerians from? So modern DNA analysis has confirmed that Sumerians were from India, Indus Valley civilization. Okay, so we'll just keep going. Okay, Sumerians. So they had a very sophisticated astronomy and so on, right? And they did a lot of number systems and all. Okay, let's move on. Okay, so this is the area where they built their cities, right? The first cities of the world. So after some time, let's move on. Yeah, so after some time, after a couple of thousand years, the Sumerians, they kind of mixed with the other races, the Akkadians and so on in the north, and they vanished totally. Okay. Later, another group called the Chaldeans moved into that area. Okay. Now people are still speculating, where are the Chaldeans from? Okay. So can this be possible? Right. Yeah. So 1500 BC, right? The Indus Valley civilization starts to collapse, right? So most historians say that these people moved into India. Is it possible some of them moved this way? It's possible, right? Why not? Okay. So could those be the Chaldeans? Okay, we'll see. Okay, so this is a figure. Okay, this is a figure of a Chaldean king and the famous Indus Valley, right? Do you see any similarities? I think the only thing is they wear the robe over the left shoulder, under the right arm. That's the only similarity. Okay, but wait till you see the astronomical similarity. Okay, this is probably going to blow your mind. So now we are going to compare the Chaldean astronomy with Indian astronomy. Okay, so Chaldean terms for the sun and the moon, Shamash and Shashin, are directly from Sanskrit. Right? The Chaldeans, so this is not some vague concept. Okay, this is something fundamental like this: sun and the moon. The sun and the moon are straight from Sanskrit. Then they employed a lunar day in their calculation. Okay, so Indian astronomy has a lunar day. Okay, and then longitudes are measured in Rashi, exactly the same as Indian astronomy. Okay, and the last one, they had a Kali Yuga. Right, so the Chaldean had a cycle, the greatest cycle that is exactly the same as Indian Kali Yuga. Okay, so what do you guys think? Were they from India? Yes. Definitely were they were. Yep. And here's something interesting. Christianity, right? The founding fathers of Christianity, like Abraham, he was a Chaldean. So Christianity was founded by Indians. Just kidding. Okay. So, circumstantial evidence, it tells us that the Indus Valley folks may have migrated to Mesopotamia in two waves. Okay, so the first wave was Sumerians 4,000 years ago for some reason. Okay, that we don't know. The second is Chaldeans, who may have migrated during the collapse of the IVC. All right, guys, so that's all I have. Thank you so much.
Yeah.